Hi. So today we'll look into this particular past year paper on P3. So as you can see above 9709 W24 and then question paper variant 31. So this should be your identification code for the past year question that I'm referring to. So let's begin. So you have a polynomial with unknown a and b, and then 2x plus 1 is a factor. When you divide by x minus 4, the remainder is 3 times the remainder when you divide by x minus 2. So the first thing that you need to do is to write down the equation. So this is the equation. So by the remainder theorem, you know that when you substitute x equals to 4, that will be a remainder. So once you calculate it, so basically you just put 4 power 3 plus 16a plus 20 plus b. So this is equals to 276 plus 16a plus b. So this should be your first equation. The second equation is when you substitute x equals to 2 inside. So similarly, you just put 4 2 power 3 plus 4a plus 10 plus b. So this is 42 plus 4a plus b. So this is the second equation. So the third equation that you can form is when you substitute minus 1 over 2 inside. This is 0. So what does this give you? This means you have minus 3 plus a divided by 4 plus b equals to 0, or a plus 4b equals to 12. Let's label this as the third equation. So the next thing that you need to do is to use the description that the remainder when you divide by x minus 4 is 3 times the other remainder. So it means that equation 1 is equals to 3 times the equation 2. So you do a simplification. You have 276 plus 16a plus b equals to 126 plus 12a plus 3b. So you simplify everything, in the end you would get 2a minus b equals to minus 75. So this will be your equation 4. So now what you need to do is to substitute equation 3 into equation 4. So how do you substitute it? You just write a equals to 12 minus 4b. So then you have 2 times 12 minus 4b minus b equals to minus 75. So you simplify everything. You should get b equals to, so this is 24. You should get b equals to 11. Then finally you substitute back into this equation. So a will be minus 32. So that's how you do question 1. Question 2, find the exact value of this particular integration. Give your answer in terms of a ln b plus c. A and c are rational, b is integer. So you integrate from 1 to 3 x squared ln 3x dx. What you need to do is to use integration by parts. So you let u equals to ln 3x. So then du is 1 over x dx. So why do you use integration by parts? And how do you choose u equals to ln 3x, basically you find the term that you cannot integrate. That's the term that you use for differentiation. So the other one will be dv equals to x squared dx, or v equals to x cubed over 3. So one differentiation, the other one integration. So now integrating from 1 to 3x squared ln 3x dx will be equals to uv. So you have x cubed over 3 ln 3x. So you evaluate from 1 to 3, then you minus 1 over 3, integrating 1 from 1 to 3. So it will be v du. So the 1 over 3 term I already moved outside. So x cubed divided by x, you get x squared again. So evaluating the front part, you will get 9 ln 9 minus 1 over 3 ln 3. So minus 1 over 3. So this one, when you integrate, you get x cubed over 3 again. So this is from 1 to 3. So you can change 9 ln 9 into 9 ln 3 square. Over here, what you have is so you have 9 minus 1 over 3. So you try to evaluate everything. In the end, you would get 18 minus 1 over 3. This is ln 3 minus 26 over 9. So then you will have 53 over 3 ln 3 minus 26 over 9. Therefore, A and C are rational. A will be 53 over 3, B will be 3, C will be minus 26 over 9. Okay, so that's question 2. Question 3, you have an equation of a curve, find the gradient at that particular point. So by implicit differentiation, so the only thing that you need to consider is to differentiate with respect to x and then differentiate with respect to y. When you differentiate with respect to y, you remember that you have an extra dy dx term. So ln x plus y, when you differentiate with respect to x, you get 1 over x plus y. And then you differentiate with respect to y, you get 1 over x plus y again. This time, because you are differentiating with respect to y, you have dy dx term. 3x squared y, when you differentiate with respect to x, you get 6xy. When you differentiate with respect to y, you have 3x squared dy over dx. So technically speaking, you don't need to simplify it because you just need to find the gradient. So at this particular point, you just substitute x equals to 1, y equals to 0. So the first term will be 1. The second term will be also 1. And then you have dy dx equals to, so when y equals to 0, 6xy will be 0. So you have 3 dy dx. So therefore, dy dx is 1 over 2. That's it. So now let's look at question 4. Show that secant power 4 theta minus tangent power 4 theta equals to 1 plus 2 tangent square theta. So I start with the left hand side. So this is the original equation. So what you need to do is to break it down into the square term. Alright. So once you've done that, you take note that secant square theta minus tangent square theta equals to 1. So you will have secant square theta plus tangent square theta. And then secant square theta is basically 1 plus tangent square theta. So in the end, you have 1 plus 2 tangent square theta, which is the same as the right hand side. Part B. Hence or otherwise solve the particular equation. So directly when you so you write down the equation first. Alright. So the left side, you can directly substitute to the identity that you have proved before. So at this point, you have two choices. Either you convert the secant square to alpha to the tangent using the identity, or you convert the tangent to secant square to alpha. So what I'm going to do is to keep it first and then move everything to the left hand side, or you can move it to right hand side, it doesn't matter. So I think probably it's better for me to move everything to right hand side. So then you notice that you can factor out 2 tangent square 2 alpha. You have secant square 2 alpha minus 1. So by identity, that is tangent square 2 alpha. So in the end, you have 2 tangent to the power of 4 2 alpha. So tangent to the power of 4 2 alpha is 1 over 2. When you root it for the fourth root, so essentially tangent 2 alpha will be plus or minus the fourth root of 1 over 2. Right? So because your answer has to be between 0 and 180 degree, so when you have 2 alpha, basically you have 360 degree. So this is the range that you need to consider. Let's put it over here. So now just use your calculator. So 2 alpha when you calculate, because you are required to answer in degree, so you need to change it to degree. So this is the first angle, second angle, third, and fourth. Divide by 2, you will get this set of answer. So that will be your solution. Question 5. Sketching a suitable pair of graphs show that this equation has one root. So before you sketch, you need to realize that for the left part, you have an asymptote at you have a horizontal asymptote at y equals to 2. So asymptote, so okay, perhaps I will write it here. Asymptote y equals to 2. This one, the asymptote is a vertical one. and this is a vertical asymptote at x equals to -1. Second thing that you need to take note is what happens with your x and y intercepts. Over here, the intercepts is 0, 3. So you just substitute x equals to 0 inside. So 2 plus e to the power 0, which is 1, you get 3. Over here, you substitute x equals to 0 inside. So x is 0, ln 1 is 0. So basically, you get 0. So these are the important information that you need to find out. So now you just sketch your graph. So for the first one, this is your ln graph. So essentially this is ln 1 plus x. So what you need to show is basically the intercept at 1 point. So this will be 2, and let me draw it properly. Yep, so this is 3. So these are the graph would be 2 plus e minus 0.2 x. So there you have it. This will be the graph that you need to sketch. So part B, show by calculation that the roots lies between 7 and 9. So you have this particular equation. What you need to do is to define fx to be 2 plus e minus 0.2x minus ln 1 plus x. So what you need to show is that the sign between 7 and 9 changes direction. So when you substitute 7 inside, use your calculator to calculate. This is around 0.1672. When you substitute 9 inside, this is minus 0.1373. Because there is this change in sign, therefore, okay, perhaps you can write some sentence. Since there is a change in sign between 7 and 9, the root lies between 7 and 9. So that's what you need to show. Alright, so use the iterative formula to determine the roots correct to 2 decimal places. So each of your iteration you need to write down 4 decimal places. So this is your equation. Minus 0.2xn plus 1. Sorry, minus 1. So make sure you key in the equation correctly inside your calculator. So you can let your first guess to be 7. Then once you calculated the right hand side, the left hand side becomes x1. So x1 you would get this value. So after you get x1 as your value, you key in the equation again, but this time your xn put answer, and then you can just keep on pressing the equal sign to calculate the rest of the guesses or approximation. So these are my calculation, you can check. So x7, x8, x9, x10, x11, x12. So once you reach 3 terms or 2 terms having the same 4 decimal places, then you can probably stop because the roots converts up to 4 decimal places. Therefore, the root, you just need 2 decimal, is 8.03. So now question 6. Diagram shows the curve and the minimum point. You have a shaded region. Given that your x coordinate lies between pi over 2 to 3 pi over 4, find the exact coordinates of M. So you need to find the minimum. That's why you need to differentiate. So if you do the differentiation, I directly apply. Okay, you know what? This will be easier. So you multiply the sine 2x inside beforehand. Alright. Then you do the differentiation. So this way you avoid using product rule. So differentiate sine, you get 2 cos 2x. Over here you have 2 sine 2x. And then multiply with cos 2x. There's another 2 term, so this becomes 4. So this will be your dy dx. And then what you can do is to pull out the value of 2 and cos 2x. What you have inside is 1 plus 2 sine 2x. So at minimum point, you know that the first derivative equals to 0. So is 2 cos 2x 1 plus 2 sine 2x equals to 0. So you study these 2 terms. Is either cos 2x equals to 0. So what are the possible solutions? Essentially, because the domain that you want to study is up to 3 pi over 4. So then basically for your cos 2x, the only possible solution is pi over 2. So x will be pi over 4. So this is being rejected because this is obviously far less than pi over 2. Okay. So the other term will be 1 plus 2 sine 2x equals to 0. So sine 2x equals to minus half. So that happens when your angle is at your third quadrant. That's the closest one. So you try to find sine inverse of 1 over 2. So you find that 2x equals to 7 pi over 6. And x will be equals to 7 pi over 12. So you don't need to find all the solutions. You just need to find the solutions that lies between the given domain. Okay. Another thing. because you need to find the exact coordinates of M. So of course, substitute back into the equation. Sine 7 pi over 6, and then multiply with 1 plus sine 7 pi over 6. That will give you minus 1 over 4. So that is your x and y. So M is 7 pi over 12 minus 1 over 4. Part B, find the exact area of the region R. So you need to find this particular point first. So you let y equals to 0. So sine 2x 1 plus sine 2x equals to 0. Okay, first one, sine 2x equals to 0. This means that 2x is 0 or pi, or x is 0 or pi over 2. So 0 obviously is not accepted because we already seen where is a 0. So over here, this one is being rejected. This one actually is being accepted. But don't trust my words. You can also do another one. 1 plus sine 2x equals to 0. Because you have two terms, you need to test. So sine 2x equals to minus 1. So 2x will be equals to 3 pi over 2. And this means that x is 3 pi over 4. Now, this is being rejected because when you look at the order, so 3 pi over 4 is over here. So 0 is over here. So that's why this is also being rejected. So therefore, x is pi over 2. So once you know x is pi over 2, region R is just the integration from 0 to pi over 2. You integrate sine 2x plus sine square 2x dx. So here you need to make use of double angle formula. So sine square 2x is 1 minus cos 4x divided by 2. After the integration, you basically get minus cos 2x over 2 plus x over 2 minus sine 4x over 8. So you are evaluating from 0 to pi over 2. Put all the values inside. You have 1 over 2 plus pi over 4 plus 1 over 2. So the rest are zeros. So in the end you get pi over 4 plus 1. That will be your final answer. So let fx equals to that rational functions. Find the partial fraction. So you can let 5x squared plus 8x plus 5 divided by 1 plus 2x, 2 plus x squared. So the first term is a over 1 plus 2x. Second term, because you cannot factorize x squared plus 2, so you have to include bx plus c. So this will be x squared plus 2. So then 5x squared plus 8x plus 5. That will be equals to a x squared plus 2 plus bx plus c multiplied with 1 plus 2x. So you let x equals to minus 1 over 2. So notice that this term will become 0. So what you have is 5 times 1 over 4 minus 8, 1 over 2 plus 5 equals to a times 2 plus 1 over 4. So simplify everything, you find that a equals to 1. Then you let x equals to 0. That will be easier for you to calculate. So the left hand side is 5. Then you have 2 plus c. So it means that your c equals to 3. So the third one, you let x equals to 1. Calculate the left side, you get 18. And then you have 3 plus 3, b plus 3. So this means that your b equals to 2. Therefore, your fx is given by 1 over 1 plus 2x plus 2x plus 3 divided by x squared plus 2. That will be your partial fraction. Now, find the coefficient of x cubed in the expansion of fx. So over here, you need to use the binomial expansion. So fx is given by 1 plus 2x to the power of minus 1 plus 2x plus 3 multiplied with x squared plus 2 to the power of minus 1. So if you want to be fast, this part you just need to expand the x cubed term. This part, because you start with x squared, so x squared multiplied with x term over here, you will get x cubed. Okay, so here you need to expand up to the x cubed term. The second one, you just need to expand the first term. I suppose for demonstration purposes, I will expand everything. So you will see. So for the first expansion, is essentially 1 plus nx, so it's minus 2x, and then plus minus 1 multiplied with minus 2 divided by 2 factorial 2x squared plus minus 1 multiplied with minus 2 multiplied with minus 3 divided by 3 factorial, and then you have 2x power cube. Then you have 2x plus 3. You expand the second one, you will get 1 minus. Okay, so probably I should explain how to do it. So remember, for all the binomial expansion, essentially this has to be 1. So you need to factorize the 2 out. So you have 2 1 plus x squared over 2. This whole thing, power minus 1. So obviously the first expansion, you just need this term. So which is why in the next equality, I simply ignore the first 3 terms. So I directly jump to that. So that will be minus 8x cubed. Then you have 2x plus 3. Okay, so 2 to the power of minus 1 is 1 over 2. So I write the 1 over 2 in front. So now you can expand. Remember to write plus dot 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 because you ignore all the other terms. So this expansion, the first term is 1, second term is minus 1 multiplied with x squared over 2. So I don't really need to expand further than that, because when you perform the multiplication, you will notice that this is actually equals to half multiplied with 2x, so you get x multiplied with the last term, so you get x cubed term. So you have minus x cubed over 2. The rest of the multiplication will result in higher than x power cube terms. So in the end you get minus 8 1 over 2 x cubed. Sorry. So therefore the coefficient of x cubed is minus 8 1 over 2. 8a, express 1 over z in the form of a plus bi. So z is given as 1 plus yi. So what you need to do is to multiply with 1 minus yi, then divide by 1 minus yi. So you have 1 minus yi on top. At the bottom you have 1 plus 1, which is 2. Sorry. You have 1 plus y squared. I automatically assume y equals to 1 for some reason. A and b are functions of y, therefore a will be 1 over 1 plus y squared, b will be minus y over 1 plus y squared. So that will be your solution. Show that the left hand side equals to right hand side. So you can directly substitute inside. You have 1 over 1 plus y squared minus 1 over 2 square plus b square minus y over 1 plus y square whole thing square. So when you square everything out, you would get 1 over 1 plus y square minus 1 over 1 plus y square plus 1 over 4 plus y square over 1 plus y square, the whole thing square again. So the first term and the last term is y square plus 1, and then you can factorize it. So you will get 1 over 1 plus y square minus 1 over 1 plus y square plus 1 over 4. So if you can't see, essentially these two terms can combine together and then factorize with 1 plus y square. So you get 1 over 4 which is the right hand side. On a single Argand diagram, sketch the locus given by the two equations. So this one means that you have a straight line, and in fact it is a vertical line. So this is something like x equals to 1. The second one, this is essentially a circle. So the center would be minus, sorry, not minus, 1 over 2, 0. And then the radius is this. So what you can do is to sketch the following. You have one straight line, so that is your REZ equals to 1, and then this is half. So you will have a circle of radius half, center at that particular point. So this is your so this part, this locus will be the modulus of z minus 1 over 2 equals to 1 over 2. So that's your sketch. Complex number z is such that the real part is 1. Use your answer in B to give a geometrical description. Geometrical description of 1 over z. So when you look at part B, essentially this is the equation of a circle, and we know that A and B comes from 1 over z. So essentially this means that this is a circle centered at 1 over 2, 0. So why 1 over 2, 0? Because of this. Okay, the radius is the square root of 1 over 4, which is 1 over 2, with the radius 1 over 2. So they want you to describe the locus of 1 over z with the real part of z equals to 1. This is essentially what you did in part A and part B. The real part of z is 1, and then you also study the locus of 1 over z through this particular equation. Okay, so that's your answer for part D. Question 9. You have a position vector A relative to O, and then there is some line passing through A. So state vector equation for L. So let's say this is your sketch. So let's say this is your A. So of course I can't draw a 3D diagram, so this is just a rough sketch. So you have another vector let's say capital X. So there is this vector passes through A and parallel to this vector. So this particular direction is, for example, AX. So we know that AX is AO plus OX. And this is parallel to, so I write the vectors IJK form into the equation, the coordinate form. It's easier for me to do calculations. So then, so what is this line L? So the line L by itself would be some number, let's say so let's say OX is X, Y, and Z. Alright. So you would have X, Y, and Z minus AO, sorry, minus OA, which is AO. So that will be 8 minus 5, 6. And this is equals to some constant K multiplied with 214, which is the vector that is parallel to line L by itself. So then your vector equation for L would be 8i plus, sorry, minus 5j plus 6k plus some constant k. If you don't want to get confused, you can use lambda multiply with 2i plus j plus 4k. So that will be your vector equation for L. Alright, so did I do anything wrong? Nope, I did not. Alright. So part B, position vector point B relative to origin is that, and line L also passes through B. Find the value of T. So then what you can say is that AB is parallel to that particular vector 214. So AB is AO plus OB. So this is equals to, for example, lambda multiplied with 2i plus j plus 4k. So AO would be the minus of that, so you get minus 8i plus 5j minus 6k plus, sorry, is minus ti plus 4tj plus 3tk. So just need to make sure that I write the correct thing. That will be equals to lambda multiplied with 2i plus j plus 4k. So you just need to find the value of t. So you don't need to compare all the things. You can just compare I and j, for example. So the left hand side of I is minus 8 minus t. The right hand side will be 2 lambda. Because you have two variables, so you need two equations. So that will be equation 1. Second equation, let's compare between the j's. So you have 5 plus 4t equals to lambda. So substituting equation 2 into 1, you have minus 8 minus t equals to 2 times 5 plus 4t. So you can simplify everything to get 9t equals to minus 18, or t is minus 2. That's it. So you have a line M with that particular vector equation. The angle is 1 over square root 6. So this is a point that the line passes through. This is a direction. Alright. So when you compare between, when you try to find the possible values of A, for instance, what you need to do is to use the scalar product, but you don't really need this particular point. You just need the direction vectors. So line L, the direction vectors is 2i plus j plus 4k. You do the dot product with ai minus j plus 3k. So that is equivalent to the magnitude of the two vectors. So magnitude of L multiplied with the magnitude of M, and then cos theta. So let's do the left hand side first. So only the I and I dot I, j dot j, and k dot k will result in some values. So what you will have is 2a minus 1 plus 12. The right hand side, for 2i plus j plus 4k, you have 4 plus 1 plus 16 multiply with the other one, which is a square plus 1 plus 9, and then cos theta is given by 1 over square root of 6. So in the end, 2a plus 11 whole thing multiplied with the square root of 6 will give you the square root of 21a squared plus 210. So you square both sides, and then you have 4a squared plus 44a plus 121 multiply with 6. You have 21a squared plus 210. Simplify everything, you would get 3a squared plus 264a plus 516 equals to 0, or a squared equals plus 88a plus 172 equals to 0. So factorize it. A plus 2, a plus 86 equals to 0, or a equals to minus 2 or minus 86. So this part of the factorization, you can do it like this. So this is a plus 286 2a. So you have something like that. Alright, equation 10, I believe this is the last question. Yep. So you have a cylindrical tank. Base is a circle with radius 4 meters. The depth is h. There's a tap at the bottom. Water flows out proportional to the square root of the volume. So first thing you need to find is the volume. The volume of a cylinder is basically pi r square h. So this is r would be 4, so it will be 16 pi times h. So what you need to do is to find the rate of change basically. So you need the you need to know how to change your rate of change. So essentially you are given that the rate of change of the volume, because the water flows out, so you need to put a negative sign, is proportional to the square root of h. Alright, so technically speaking, you can leave it like that, because you need to show this. Alright, so dh over dt would be, sorry, you need to find another thing. Okay, let's differentiate v with respect to h first. So you will get 16 pi. Alright. Then just now we know that dv over dt is the minus of k times square root of v. And what do we know about v? V is 16 pi h. Let's keep it that way. So dh over dt will be dh over dv times dv over dt. So dh over dv will be 1 over 16 pi. dv over dt will be minus k times the square root of 16 pi h. So you have a minus sign. 16 square root of that will be 4. So you would have k times square root pi over 4 pi, if not mistaken. Yep. And then you have square root h. So because I initially over here I already assume that your k is positive, and why k has to be positive? The constant of proportionality has to be positive, because I already assume that your water flows out of the tank, so the rate has to be negative. So I already sort of like preemptively take out the negative sign. So it means that k has to be positive. Is a positive constant. K cannot be negative, because if k is negative, then it means that you are adding water in, because it will cancel off with the negative sign. So this is minus lambda square root of h, because everything on this part is positive, where lambda equals to k square root of pi divided by 4 pi is a positive constant. So that's how you show that particular equation. Time t equals to 0, tap is open, hash is 4, when t equals to 0, hash is 2.25, t equals to 20. Solve the differential equation. So essentially you are given two initial conditions. So the differential equation is dh over dt equals to minus lambda square root of h. So you integrate dt on both sides. You would have integrating h minus 1 over 2 dh equals to minus lambda dt. Lambda is a constant, so you don't need to integrate it. So once you integrate the left side, you will have 2h 1 over 2 plus some constant of integration constant minus lambda t. So you want to write t in terms of h. So t would be minus 1 over, 2 over lambda square root of h plus some constant. I don't need to be worried about what is the value of the constant at this moment. What I need to do is to substitute all the initial conditions inside and find out the value of lambda and c. So when t equals to 0, h is 4. So 0 equals to alright, perhaps it's easier if we do it this way first. So when t equals to 0, h is equals to 4. So the reason why I think this is a better way to solve it is because then I don't need to worry about the lambda at the moment. So when t equals to 0, 2 square root of 4 plus c equals to 0. So square root of 4 is 2 times, so c is minus 4. When t equals to 20, h is 2.25. 2.25 square root of that minus 4 equals to minus lambda times 20. Simplify everything, lambda, you find that this is 1 over 20. So finally substitute everything into the equation. You have minus t over 20 equals to 2 times square root of h minus 4. So you can write t to be minus 4d square root of h. Minus times minus becomes plus 80. So that will be your equation. So find the time taken to empty the tank. When the tank is empty, it also means that h equals to 0. So t will be equals to 80. So that's the solution for the whole paper. Thank you.